Forces! So we've been studying forces for a little while now, and we know at this point that if there aren't any other forces other than gravity acting on you, you're just going to fall straight down with the acceleration of gravity of 9.8 meters per second squared. But other times, there are multiple forces acting on you. Gravity's pulling down, the water's pushing back up, and there's the force of the tow line. So this is a more complicated system with multiple forces to consider. Well, here's something we've been looking at lately. We have a brick sitting on a table, and it has two forces acting on it. The force of gravity pulling down on it, which is the brick's weight, and the normal force, which is equal and opposite to the brick's weight, which is why the brick isn't falling, because these two forces balance each other out. But what happens when we tilt the table? Well, does gravity point in this direction? No. Gravity doesn't point that way. We all know what gravity does. That's right, gravity points straight down. But the normal force is still going to be perpendicular to the table. So now these forces aren't pointed opposite each other. So how do we figure out what the normal force is now, if it's not just equal and opposite to the brick's weight? Well, let's take a look at this a little bit more closely. So, if we tilt the table at an angle of 30 degrees, the weight of the brick still points straight down, because gravity doesn't care what the tilt of the table is. Gravity's always going to pull the brick straight down. Now, there's a component of the force of gravity over in this direction that acts perpendicular to the table. And the way that we find that is the angle between the weight of the brick and that perpendicular component is the same as the angle of the table. So if the slant of the hill or the slant of the table is 30 degrees, then this angle in here is also going to be 30 degrees. So now that we know that, we can use trigonometry. So before we do anything else, we want to try and make this problem as easy on us as we can. Since the brick can only slide along the surface of the table, and we don't want the brick to be able to move in more than one direction at a time, we just want to keep it in the x direction, we need to change our coordinate system a little bit. We want to turn the coordinate system so that the positive x direction points up the hill. So now this is the positive x direction, straight up the hill. And then the positive y direction is going to be this way, perpendicular to the hill. And this will be plus. So now the x direction is parallel to the surface of the hill, and the y direction is perpendicular to the surface of the hill, and that'll make things a lot easier. So the best way to take a look at this is to look at a free body diagram. So here we have our brick, which is just a dot, and here is the force of gravity pulling down on it, which is the brick's weight. And to find the component that is pointed into the hill, it's just the weight times the cosine of the angle, just like we've been doing. And that's going to be negative. So the normal force which is perpendicular to the table, is just going to be equal and opposite to that component. So if that component is the weight times the cosine of 30, then the normal force is also going to be the weight times the cosine of 30. They just point in opposite directions. So if there's a component of the weight that points into the table, there's also a component of the weight that points down the table, which is why things tend to slide down a hill, because of this component, which is the weight times the sine of the angle. So let's take a look at an example. So here we have a 5 kilogram brick sitting on the surface of a table that's being tilted at an angle of 30 degrees. And we're going to take a look at all of the forces that are acting on our brick. The first force we're going to look at is the force of gravity pulling down on the brick. Now gravity doesn't care that the brick is on a table that's slanted. Gravity is still going to point straight down. Now the force of gravity is simply the mass of the brick, 5 kilograms, times the acceleration of gravity, 9.8 meters per second squared, for a force of 49 newtons. Now, unfortunately, this force doesn't point in the x direction or the y direction, so we're going to have to fix that. Now, our weight has a component that is perpendicular to the table, and a component that is parallel to the table. And it just so happens that those are our x and y axis. And better yet, this angle in here, right here, is the same as the slope of the table. So we could just take that 30 degrees and put that right in there. And now we have our two components and the angle. Let's get this out of the way, and we'll see what happens. So here's where you're going to have to be extra careful, because the y component, this one here, is the one that's adjacent to our angle. So to find the y component, we're going to use the cosine function. So we do the weight, 49 newtons, times the cosine of the angle, and we get negative 42.4 newtons. It's only negative because it points down along our negative y-axis. And then for our x component, we do the weight times the sine of the angle, and we get negative 24.5 newtons. And again, it's negative because it points in our negative x direction. Alright, so here we are. Now, let's get this 5 kilograms out of the way. So, now we know the y component of the weight, negative 42.4 newtons. We know the x component of the weight, negative 24.5 newtons. So, we only really have to find the normal force, and the normal force is going to be just equal and opposite to the y component of our object's weight. So our normal force just equals 42.4 newtons. There's nothing else to calculate. Those two forces have to cancel each other out so that they add up to 0. Now, why does the brick slide down the table? Well, the brick slides down the table because there's a component of force, the force of gravity, pointed down the surface of the table. And that is just equal to our x component of our object's weight. And that is forces at an angle. Please make sure you take really good notes on this. See you tomorrow.